And we were talking last class about variables, right? Um, variables are names. They're going to contain values, and we can change those values, right? Variables have a name, a type, and a value, right? We talked about integer variables. Thank you.
Oh,
Yes.
before you get started, on the assignments on the due dates, you said just put a week in front of each one of them.
Yes, I actually replaced it, right? On the due date,
But
if you go to the due date thingy, you will see.
it's the same.
Assignment 0 is due on the. God, I am an idiot. And that may be why you're getting confused. I changed this. And didn't commit. I am an idiot. As you notice, right, all the nodes on GitHub. It's the same thing as GitLab, except that GitHub only does free public ones. But I'm using Git, just like you are, for your assignment 0, to keep track of the nodes. What were you saying? Now good. I fixed it. Sorry. I messed up. I didn't commit and push. I changed it on my machine but didn't push the changes. Now it's good. There will be changes to the second half, but I don't even remember where. It's normal. First week is chaos. I think I am done with everybody who sent me stuff for your assignment 0 up until like yesterday at 9. And then I stopped working, and so if you sent it after something like that, then I haven't. I'll probably do some more tonight. And I'll have a chance to go look at your pull requests probably tomorrow.
Were you saying you're still adding some people to GitLab?
I'm still adding some people to GitLab if you never sent me.
I mean, I sent mine before class started on Monday, and you like confirmed it in email, but my GitLab never got anything.
Sorry? Oh, I didn't.
Yeah, it just didn't get sent to me. You confirmed me in email. You're like, got it, but then I never got the GitLab invite or whatever. Which we can look at.
Send me an email. Yeah,
Okay.
and I'll go look. Politician's promise. I may not have made it, or I may not have created. Like, I tried to reply to everybody's email, just saying done, and a link to the thing, but maybe I didn't.
Okay.
Like that is why I'm doing it, because yes, I will mess up. I am horrible at being a computer. Computers are really good at dealing with, which is why I make you guys submit on GitHub or something like that, because then a computer knows what's being done, not me. Okay, so if you sent it before and you haven't heard from me, remind me, because I probably messed it up. If you sent it after, like if you sent it before 8 or 9 yesterday, yes, yeah, and you didn't receive anything, then it's my mistake. Send me a reminder. Let me ask you guys something. Did you guys get, besides my email, did you guys get something from GitLab about the repo being created and you getting access to it? No. Okay. Then I will make sure that I send you guys the email. Oh yeah, and I need to go change my assignment 0, because somewhere in here I still have spring 17 and it should be fall 17. on the actual instructions for cloning repo setup. This one.
Yeah, I was typing
It
in
should be-
spring,
yeah,
like
I am
really
an idiot.
stupidly, and
No.
and I realized it's fall. And then when I realized it's fall, I made another syntax error, and it still didn't work. And I thought, oh, I'm doing this wrong. And then I finally figured it out.
Bless you. Well, that's it. That is it, and it should work. Yes.
You still have the S in there from spring.
Sorry?
You still have the S from spring.
5K.
Did I?
Since KS fall.
Thank you. Pair programming is cool. Thank you. Cool. Hopefully most of you have done that and have tried, and it is perfectly okay. Let me tell you this. It is perfectly okay to feel lost this week and next. It is normal. You are doing stuff that is different, right? After next week, if you're still lost, then worry, right? But right now, it is perfectly okay for many of you to feel lost. You have never done this stuff. You have never gotten used to something where you have to type something, and if you miss a space, right, the computer interprets it completely differently and yells at you, right? That's as a programmer, you get so used to that, but it's not normal, right? And so it will feel weird for a little while, right? And it will get a lot better, I promise. So let me go back to material. We're talking about variables, right? We talked about integer variables. We declare a variable like this. We assign values to variables like this, and we can't change the values, right? What is on the right-hand side is called an expression, and also the little pieces are expressions. So in this case, we have an expression 3 plus 4, which is composed of two expressions, 3 and 4, joined by the plus operator, right? We can also declare and initialize. We talked a little bit about variable names. Letters, digits, $sign, and underscore, and you cannot start with a digit because it would think that you're typing a number. And then the important thing, although I'm going to be breaking it, is use meaningful names, right? In Java, we have a very strong convention to use camel case. So variable names start with a lowercase letter, and if you have more than one word, the beginning of each word is capitalized. Basic integer operators, we have plus, minus, times, which is an asterisk, divide, which is integer division, and percent, which is integer remainder or modulo, right? We can mix and match these with the usual order and also add parentheses, right? To modify the order and get this to be as complicated as you want. Java has shorthand operators. Instead of writing this, you write this. A plus equals 5, and that just means A equals A plus 5. right? How much is A gonna be?
A plus 3. Oh, shoot.
The plus plus operator just increments by 1. And you can actually do it the other way. What does this do? Subtract 1 and then add 1, right? Ooh, but it didn't work.
You can write that?
Not that, but no. Okay, you can. But you can write that. Plus plus and minus minus are don't return values. They do sometimes. It's good. But you can actually, and this is horrible, right? Because you actually have 2 assignments in one expression, and I don't know about you, but I get confused as hell. How do you solve that problem? Don't ever write code like this, right? Project it in a code review. You can also go read the rules and become a language lawyer, but it's a lot easier to just not mess up in the first place. Now I need to do it. Yeah. Okay. Oh, what you can do is A equals plus plus A plus A plus plus. Yeah. That you can do. And that's confusing as hell, don't do it. There is actually a slight difference between A++ and ++A. If you use them as an expression, they return a different value. If A is something, yeah. A is 68, A++, A is gonna be 69, right? But A++ is gonna return 68. A got incremented, but the result of this expression is 68. Whereas if I do ++ A is now 69, so ++ A is gonna return 70. First does the increment and then returns. Does that make sense?
Yeah.
Is it terribly important?
Not really.
No, because if you do it, if you're ever in a position, if you write code where this matters, you are doing it wrong. Right? You are going to confuse the poor guy, the poor sod who's going to go look at that again. And that poor sod may be you when you're trying to get out of the office quickly, right? So don't write bad code. Don't write confusing code.
What
Yeah.
exactly is A being incremented, but it's not equal to that value yet? What?
Well, it's one, this have side effects, right? The side effects is that they increment the A, but they also yield a value as an expression, right? Just as if you were saying A plus 1, right? What's the value of A plus 1?
71.
71, right? So as an expression, they yield a value, right? So plus A is gonna increment A and then yield the value of the new A. So the incremented A. Whereas A plus plus is gonna increment A but yield the previous value before incrementing. It doesn't terribly matter. Most people, or pedantic people, tend to write plus plus A because it's officially slightly more efficient because you don't need to keep the old value around. So I tend to write all my loops with plus plus a. It doesn't matter.
So if you were writing something, could you use that? So if you're writing something that gave you a result based off that value, like you wanted it to give you a result at 69 and then 70 and then 71, would you be using?
Yes, but in a for loop, which we'll talk about later.
Okay.
This is basically not terribly important, but we need to mention that it works like that because you'll see it written both ways, and occasionally it actually has a different meaning. Normally, it doesn't matter. When you have a chance, go look at these things. Integers in Java. This. Yeah. Integers in Java are 32 bits, and they are signed. So what that means is that it goes from minus 2 billion and peanuts to 2 billion and peanuts, and these are the actual peanuts. Notice that it's not the same number. Why not?
Because there's 0.
Because of 0, right? And 0 takes off one of the positive numbers. Does this make sense? If you need bigger integers, we can declare longs. And a long just allows me to do 64 bits, so it's about 2 billion squared. So what 4 billion? Billion is 10 to the 12, so squared is 10 to the 24. I have no clue what you would call it in English. It's like 6 billion or something like that. But other than that, it behaves like an int, right? Now, floating point numbers don't behave like ints, right? Floating point numbers use scientific notation. What is the deal with scientific notation? Well, imagine that I'd ask you, how far is the moon from the Earth? Does anybody knows the number? No. How big is the Earth's circumference?
25,000 miles.
Probably, yes. Yes, 40,000 meters. 4,000 kilometers. Right. How precise is that? Meh, right? I mean, it is relatively precise on the meter because they used to define the meter that way, right? But it's still not very precise, right? Let's say 40 million meters. Well, maybe 40 million 50,000, right? I mean, you don't terribly care, right? Talking about millions, what's a few meters more or less, right? Scientific notation is that same idea, right? So rather than saying a million, I say 1 times 10 to the 6, right? And if I'm saying a million, right? A million and $1 are very close, right? I don't terribly care. So when I'm doing scientific notation, I can reserve some bits for the mantissa, right? For the piece that has the digits, 1.23 or something like that, times 10 to the 6, right? Or times 10 to the 12. And reserve some other bits for the exponent, right? These allow me to represent a huge range of numbers, but they are imprecise, right? So in scientific notation, or in floating point numbers, 1 billion and 1 billion and 1 may actually be the exact same number. They have the exact same bit representation. There is no way to distinguish among them. Does that idea make sense? Just like if you were doing scientific notation and you have a fixed width for your significant part. Right? It's really cool because when you're talking about large numbers, right, it is okay to have relatively large differences, right? If we're talking about billions of dollars, $1 or $2 don't matter. If we're talking about $5, then $1 or $2 do matter because it's 20% of this stuff, right? And so floating point numbers expand, their accuracy expands with the size of the number, or the other way around. The accuracy decreases with size of number, so they are within a percentage point of the number or something like that. The other hand, they behave really, really weird. They're not mathematical anymore. Like, they are, but they're not, right? When you add up two floating point numbers, maybe you get the same number. Because it's two tiny numbers, so they're close to zero and gives you zero, right? Horrible things like that may happen. They also happen with ints, but with ints it's always because you overflow, right? If you add 2 billion plus 2 billion, what do you get? If you add 3, 6, 9, that's 2 billion, right? 2 billion in English. What am I expecting to get? 4 billion, right? What did I get? No, I got negative 29 something. Sorry, you cannot see that stuff, but believe me.
The max and what it was?
Something like that, right? It basically overflowed, so it lost the most significant digits, the binary, the bits 33 and 34, or something like that got lost. So you just get a random number, right? And it happened to have a 1 in the most significant digit, so it's interpreted as a negative number. But it's basically the wrong answer, right? Because it just went over as if you were doing, probably in elementary school, right? You have like 3 squares or 4 squares, right? If you have more squares and you just lose that last thing. Computers use one of those squares for plus or minus, and so you end up with negative numbers. You could do longs, and that will work. If you put an L next to the number, then it becomes a long, and that's an L, not a 1. So that would be okay. But my answer is now a long rather than an int. For most of this class, it doesn't terribly matter, right? We're not going to do stuff with huge numbers, but it's a good idea to be aware of whether you can use ints or not and things like that. Do you have this idea of floating point numbers? If you don't, what do you do? Go play. 0.1 plus 0.1. What happens? Oh, 0.2. What happens if I do? That's cool, but what happened? What did I get, right? 1, oh, I got a 1, e6, that's good. So, that's still good. What happened with this one?
Just erased it.
It's so small that it doesn't matter, right? And so it said, oh, that's 1 e to the minus 6. So that's 0.00001. Does that make sense? Probably make it better.
Does it indiscriminately decide that it's so small of a number? Is there like a threshold for when it says like this doesn't matter? Like is that set by a person or by?
It is by what what it does internally, right? It does it in binary, not in decimal, so it actually has nothing to do with what you would expect. It has a set number of digits for the, I call it mantissa. Is that the right name in English? The significant part. When you're doing 1.0 e to the minus 6, the 1.0, what is that called? Do you remember your scientific notation? Oh God, you're worse than me. I remember it, but in Spanish. It's called mantissa, right? At least one of the names is mantissa. Yes, it is mantissa, a significand. It is mantissa.
I don't remember that from high school math. I remember scientific notation, but
Basically, what is happening, right, is doing, okay, what this will do is it would need to imagine that we are doing it with one digit only, right? I only have one digit. If you do 5 plus 5, right, I can do 1 times 10 to the 1, right? Or 1e1, or something like that, right? If you do 5 plus 6, right, what happens? It's coming? Maybe. It's coming, but it's taking forever, yeah. If I have, I have one digit of precision, right? Let's say 2 for exponents. And I'll use it as digits, right? So if I have 5 plus 5, right, it's going to be 1e1, right? 1 times 10 to the 1. If I have 5 plus 6, what's this going to be? 1e1. Why? Because, right, I ran out of digits there. If I had, say, 2 digits, right, then I could have, say, this 5 plus 5 would be 1.0, right? And this would be 1.1, right? E1. And when would I go in trouble, right? When I do something like 55 plus 56, because this would be 101 E1, which cannot do, so this would be 1.0 E2.
and it always rounds down.
Maybe, no, it tends to round, right? The thing is that this is closer to 100 than to 110, which will be the next one. Does that make sense?
Okay.
So if you had 5.5 would really be 5.5 E1. This would be 5.6 E1, right? But if we had 5.8 and 5.8, this would really be 1.1 E2. So this would count it as 110, right? Because it's 58 plus 58 is 106. Actually, no, I went too far. This would be 120 because it's 116. So it would round up. Doesn't necessarily round down. If you get into the details, you can actually tell it how to round and horrible things like that.
Okay.
For the most part, assume that it behaves like real numbers, and sometimes you lose precision and get weird stuff. At the level that we care about it in this class. Does that idea make sense? There are floating numbers in Java follow the IEEE standard, so you can actually go read exactly what it's supposed to do. It's just boring and convoluted. you don't care unless you're writing mathematical algorithms, and then you do care a lot. How do you think accountants like floating point numbers?
They probably don't use them.
They hate them with a passion, right? Because if a penny is missing, I need to go find out where the heck that penny go, not because of the penny, but because maybe something is wrong with the core algorithm and now your number is pure BS, right? But in science, we tend to use it because we understand that, close enough, right?
And you can't tell the SEC that, oh, it was a floating point, you know.
That doesn't
Lost
work.
$1 million.
Although, right, actually you can. Your IRS forms, you only need pennies. You never have to be more precise than pennies. So you do, you can. I think you can even round down when you submit taxes.
Well, yeah, but I submit $1 trillion tax return, you know, so
Yes.
I can't use floating points for that.
There are two kinds of floating point numbers. There is float, which have 32 bits, and then doubles, which are 64-bit floats. Now the range is much bigger, right? Because you have those exponents, so it could be 10 to the 32 or something like that for the range. Sorry, 10 to the 2 to 32. 10 to 2 billion or something like that could be your range. So it's much larger ranges, but imprecise. Another interesting thing, floating points are never equal, right? So we could ask whether two numbers are equal, and we may not get what we want. In this case, we did get true. But floating doesn't really make sense to ask for equality of floating points because the numbers are imprecise. So it's like, is 1 billion equal to 1,000,001? Maybe. But so we have floating point numbers. The normal arithmetic operators work for ints, except that division actually does floating point division, the one that you would expect, and percent doesn't work, right? So 1.0 times 4 divided by 4 is 0.25. 1 divided by 4 is what? 0. 1% 4 is 1. No. 1% actually works, just weirdly.
How far will it take out like never-ending numbers like pi?
Sorry?
How far will it take out like numbers that never end like pi or something?
Depends. Somebody would have to have defined it. So math.pi has this many. But somebody just wrote that number. Most of the times, floats, right, the 32-bit ones are seldom used because doubles have more precision, and usually at the level that we are working, you don't terribly care about time. It takes about the same to do a float or a double. You can do a gajillion of them in a second, so who cares whether it's a gajillion of half a gajillion. And so we tend to not care. Most of the math operators operate on doubles. And so they convert from a float to a double and do stuff in doubles. And maybe bring it back to a float if you need to. But we can, if you guys really care, we can actually do Java double precision limit. So 2 to the minus 1,000 and then 2 to the 1,000 or so is the max number. But then you go losing precision. Actually not that good. Java actually, although we'll probably not use it, has a big decimal class that allows you to represent numbers with unbounded precision at the cost of being way, way, way less efficient. Normally there is hardware for floating point operators, so they are not slow at all. This is all good?
Yeah.
Cool. Now, let's introduce another idea. What is the simplest data type? Boolean. You only have two options, true or false, right? Stuff is either true or false. That's it, right? There is no modernist philosophy. There's no stuff in the middle. Stuff is either true or false, right? That's it. You only have one of them, either true or false, one bit, either 1 or 0, right? When do we use this? Well, we use it all the time, right? If I say today is Tuesday, it's either true or false, right? Does that make sense? In computing, we call those the data type, right? Boolean. We can have Boolean variables that can contain either true or false. That doesn't sound too terrible, except that we actually think of them as just values that we put operators on them, right? So what kind of operators can we do with Booleans? What kind of stuff do we do to truth besides bending it and hiding it? Sorry?
Okay.
We could compare, right? That's one. What's the answer of those comparisons, right?
And or.
Exactly, but what's the answer when I compare two numbers, right? What kind of stuff is the answer? Is 3 greater than 4? What's the output? What's the type of the output? It's a Boolean, right? We get, right? Or the relational operators, the comparison operators will get us true and false, will get us Booleans, right? And then we use and or and those guys to combine Booleans, right? Does that make sense? So if I have this, B1 equals true, B2 equals false, and this horrible thing will only let me do one line at a time. I need to redo this one. B1 is true, B2 is false, B1 and B2, and we use the double ampersand for and. But actually, it's just as if I was doing plus or minus or something like that, right? It's an operator and it now returns another Boolean, in this case, false. They both have to be true for it to be true. With an or, I get true. Or works is an inclusive or, right? In English, what does or mean?
In English it means both, but in logic it means one or the other.
Well, actually in English, it sorta means both, right? If you ask a kid, what do you want? Ice cream or cake, right? You are implying that they should have one of them. What's their obvious answer? If you ask an adult, they'll answer the same way. What's the answer to that question? Cake or ice cream? Both, right? I mean, hey, what the heck are you asking, right? Of course I want both, right? It's, right? So there's an implication in English that not both, but it's actually not true, right? Both could be a very reasonable answer to cake or ice cream, right? And so in English, we kind of sort of imply that both is not the right answer, but sometimes it is. right? In logic, we say, okay, when you say or, it's either one or the other or both. Does that make sense? And so that's slightly confusing, slightly different than English, although in English it's just unclear. We also have the not operator, which is written with a bang, with an exclamation point, and that will just invert it, right? If we want to write an exclusive OR, we can. B1 or B2 and not B1 and B2. In this case, it's okay because B1 and B2 are different, but if I made B1 is true, B2, if I make true, then this expression would now return false. And I can't write horrible expressions like that, right? Does that make sense? Sorry.
So you can change those B2.
They are variables, I can change them.
That's what I was saying. So what if you say B2 equals 10, and will it change from a Boolean?
Good question. In Java, no. In Java REPL, maybe. In Java REPL, it will. In Java, you get a compiler error. The compiler yells at you and says, no, wait, you told me that that thing was a Boolean, so you can only put true or false in there. You can't stick integers into Booleans. It's a square hole. You can only put square things in there. But Java REPL is not quite Java. We have not, which is the bang. We have and which is and or, right? And we use 2 ampersands for and 2 vertical bars for or. Homework. Go find out where the heck is the vertical bar on your keyboard. It's probably different for everybody. It's usually above the slash, one of the slashes. In some keyboards, it's supposed to have like a hole in the middle. It used to, but not every font does it, right? So I can define stuff like this. Boolean earth is round equals true. Boolean earth is not round equals not earth is round, right? Notice that my variable names basically say this is a proposition, its value is true or false, right? Do I compare things with true? Do I compare Booleans? Seldom, right? I don't need to compare a Boolean. If it's true, it's true. I don't need to say, is this equal to true, right? Whereas I do need to say, is this int equal to 0 or equal to 25? Because ints are not Booleans. Booleans are Booleans. I don't need to compare them. Seldom, but again, it's not terribly important now, but this one is important. It's just delayed effect. Java does short circuiting. When you do this or that, right? First evaluates the first piece, and that if the first piece is true, it doesn't evaluate the second piece because it knows that the answer is going to be true. Does that make sense? If you're doing an and, if it evaluates the first piece, it doesn't evaluate the second piece because it knows the answer is going to be false. Does that make sense? No.
So
Okay.
it's only a problem if you write a complicated program and it evaluates to true and you think, oh, I've got everything's fine.
If you're using side effects, it is a problem, right? If the two things do other stuff besides just computing true or false, then it is a problem, right? Imagine that I have this, int a equals 5, int b equals 10, right? If I have a greater than b, or b greater or b greater than a, right? What's the compiler gonna do when it sees this, right? Or the actual code generated by the compiler, right? Well, it evaluates this, a greater than b. Is that true or false?
That's false.
False, right? Oh, then I need to go look at the next piece. Because I don't know what the answer. If the first piece was true, I don't need to look at the second piece. Right? Because I know that the answer is going to be true.
If they equal then.
What's equal here? Or, no, like, if I have it the other way around, right? B greater than A, or A greater than B.
So they only look at the other side.
It will only look at the first side, B greater than A. Is that true?
Yeah.
Yes. I don't need to look at the second side. Whatever the second side is, right? The answer is true, so I don't need to evaluate the second side.
So the first side false, they're gonna go to the other side. Sure.
For ORs, for ANDs, it will do it the other way around. This is called short-circuiting, right? If you know the answer to the whole expression, you don't need to evaluate the second piece. Why is this important? Let me confuse you guys, right? More. What if I do something like this? Don't ever do this. This returns true. What are the values now of A and B? A is 6, got incremented. What's the value of B? Did B get incremented? Did B get 10 more?
I guess not.
No, because we did short circuiting. Does that make sense? If your code does this, you are doing it wrong. Right? Don't do this. But it may be something where you have like A not equal to 0 and A or B divided at A greater than 1, for example, right? In this case, this is guarding me from dividing by 0. Does that make sense? So like we tend to use it like that to guard against conditions, but not to do side effects. So we use the fact that short-circuiting works, but if you do horrible things like this, you are making your life a whole lot of pain for no particular reason. Make sense? So that beautiful deal, just remember short-circuiting exists. We do have relational operators, right? Comparison operators that compare two things. Since we use the equal sign for assignment in Java, we need the equal equal, which checks for comparison, right? So if I have A equals 1, what does this do? A equals 1 compares, and so A never changed. Does that make sense? I also have bang equal, not equal, and then less than, greater than, and then less than or equal and greater than or equal. Does this make sense? And then I can combine these things with more booleans, right? A greater than or equal to 1 and B less than 17. And combine it until I get really tired. Does this make sense? What if I don't want to write very convoluted expressions?
And don't
don't program now. Besides that, I can write variables, right? Int a is big equals a greater than 100, right? Yeah, sorry. Does that make sense? So I could be writing something for, if this actually had meaning, for this guy, right? And this guy, and then combine. So my individual expressions don't have to be big and convoluted. At the cost of writing more lines of code. That idea makes sense?
So you're saying instead of having that full information there, you would have just said integer.
Instead of having all this thing, right? I could do Boolean part 1. I didn't have any meaning, right? When I wrote this, it didn't mean anything. So let me call it part 1 and part 2. And copy this. Ah! Sorry. This is horrible. This stuff doesn't work. This is part 1. Boolean part 2 equals this other stuff. And then I can just write part 1 or part 2. Does that make sense? I mean, you can go either way. Chances are that at the beginning, you would want to do it more like this, and as the class progresses, you write it more like the other way. Within limits, right? At some point in time, especially if you can come up with meaningful names, part 1 and part 2 would probably not be very good. But if these things actually have meaning and you can give them meaningful names, that makes your code much easier to understand. And who is going to be reading and understanding your code? Other people, and then you, because you need to debug that thing, right? Normally, you need a lot more brain power to debug than to write code. So if you write the most complicated code you can write, you're going to have a really hard time debugging it. Make your code simple, write simple stuff, right? Write it so that even you can understand it. And life will be good, because you will understand it and you'll be able to debug it, and life will be good. But naturally, you will be able to do stuff slightly bigger. Let's do something. What will be the value of ans at the end of the following code fragment? Int a equals 10, b is 20, a is greater than b equals a greater than b. It's greater than a, and so a is greater than b, or is a greater than b, sorry, or is b greater than a. What's the answer of that? What's the value of that? True, right? What do you do if you're confused? Go to Java repo and test it, right? Or do it step by step, but also go to Java repo and test it. What do you do if you're still confused about floating points and ints and booleans? Go to Java repo and play with it, right? When do you stop? When it hurts, when you have to go eat, when it makes sense, right? Hopefully, when it makes sense, right? Come back to it, you can do it again until it makes sense. How many repetitions do you need? I have no clue whatsoever. Who is the only person who can know? You. Go do it, go practice. Programming is a contact sport. You need to be doing it, right? You need to be doing it every day. And then life will be good, you'll ace the class, you'll feel good about yourself. The other data type that we are going to be using is strings. We tend to do letters, right? And then words. A string is kind of a word. A letter is called a character in Java. you can declare characters, and we use single quotes to denote characters. So A is one character. We use double quotes for strings. A string is a bunch of characters, a bunch of letters, right? They're not necessarily letters, because I could do hello space world bank, right? And so it's not just letters, right? Letters each, right? Does that make sense? Maybe I can do this again, maybe. Make it bigger. Oh, I need to be outside. What else can I do with strings, right? First of all, I can build them, right? I can build constants with double quotes. I can also, and we'll talk more about this, I can declare variables. Strings are capitalized, so it's capital string word equals word. String. I can also, and we will see, a string is actually an object rather than a primitive value like int. And so I can call methods on strings. So I can do word.length. And the string would tell me its length. Does this make sense? For now, wave your hands with me. We'll actually talk about using objects and the exact syntax and things like that. But that doesn't mean that you cannot start practicing right now. I can also use one operator on strings. Which is the plus operator. And the plus operator adds or concatenates the two strings. I have characters. I have length. I have equals for compared strings. Concat, which is the plus. I can do other things. I can do word.to uppercase. That just converts it all to uppercase. I have to lowercase. I have equals. Equal is dangerous on strings. Don't use it. Sometimes it works, but not always. We'll see in a week or two why. But objects also have compare to, which will return -1, 1, or 0, or actually negative, positive, or 0. Not. So compared to ABC is bigger, which means that word is lexicographically bigger, right? Alphabetically, it would come after in the dictionary, right? It starts with W versus a. So if I had here Z, then I would get a negative number. And if it was the same, I would get 0. Let me just check. I think we can do this. We can also concatenate one string with a character, but not, maybe. I don't think we can concatenate two characters. Oh, we can. Oh, but what happened? A character is really just a number, just a short number, it's 1 byte. And so it added them as ints rather than concatenating. Why is a character just an int?
Is that like, are those the two ASCII values added?
Yes, basically, right? computers only do numbers. Computers only do binary numbers, right? And we combine that. And so people sat and said, okay, 26 is A and 27 is B and so on, right? And we have ASCII, which was the first 127, so it was 7 bits. It contains all of the English letters, uppercase, lowercase, all the digits, and a bunch of punctuation symbols. It didn't quite work for other European languages because you have all the accents and umlauts and weird things on top of letters. Everybody kind of expanded the ASCII, and so you would have Mexico would do Spanish, and so they would say, oh, 130 is A with an accent. And the French would say, oh, my A with that same accent is 142, right? And so they have code pages and stuff like that. They're still mildly used. For the most part, everybody either writes in English or uses Unicode, right? Because for European languages, it wasn't that terrible, or for most. But there are languages that have way more than 26 letters, right? I don't know much about languages. We have people here from all over the world, so you can tell me cool things about your languages. Chinese uses an obscene number of characters, right? Because they represent, it's almost like a word per character, right? Maybe. I think they are the only ones who do that, but I think Arabic uses letters, right?
We use under 44.
You use what?
Under 44.
144 letters in Arabic? In-
No, Amharic.
Amharic. What is that from?
Ethiopia.
Ethiopia, okay. So 144 characters, right? Who else speaks languages that don't use? I speak Spanish. We just have some weird accents. And actually relatively few weird accents. The French use the other accent too and other stuff. But so there is tons of different languages and stuff. Unicode does kind of 16 bits, so you can have 65,000 and then all sorts of weird stuff because some languages need more than 16 bits. For the most part, in this class, we'll program in English and you will never have to do any of those things. It's one of those things that is actually interesting and cool, but also stuff that I normally don't want to deal with. If you need to deal with, what do? Google Unicode representation and go figure it out, right? All the information is there, it's just you're going to be complicated with other stuff. One cool thing about strings, I can do char at, and we'll be using this later. And that will return me a character, right? So word is actually a string that contains the word word. And so if I do char at 0, would return the first character, which is W, right? And then char at 1 would return the O, and I can combine these things, right? To uppercase dot char at 1 plus and combine things, right? Basically up to any length of stuff. Does that make sense?
Is it like when you're working with integers and now that string is forever changed to be what you just did, like it's going to change it to have a capital O where you put that?
The string was never changed.
Okay.
To uppercase returns a different string with all these, right? I'm not making the string uppercase. I'm just transforming the value. The string doesn't change. Word is still lowercase WRD. So to uppercase returns a different string with all uppercase, and then char at returns one of those letters. But the original string is never changed.
It's never changed. Okay.
But what are the plus double quotes?
Again, the
They keep
plus
going around the zero.
takes two things and returns a new one, but doesn't change any of the things. Right?
Yeah, but how? Okay.
This is a character, and this is a string, so the plus concatenates them into a string.
You just added an empty string to it?
Yeah.
Oh, okay.
A string has the empty string, which is a string with no characters. It's a perfectly valid string. It's all cool. I can ask it things like its length. What should it tell me? And I can concatenate it and do all sorts of things to it. Make sense? We have about 5 minutes ish, right? This one is 6:30 to 7:45. Cool. Yeah, I'll let you go through this stuff on your own. Let me prime your brain with module 1. Because this is one of the most important concepts. Functions. Functions allow us to define a procedure and give it a name and apply it to different values. So I could define a function called isEven. I'm saying what does it return, and I'm saying what does it take. It takes one parameter, which is an int, and within the function I'm going to call it number. So the value that it's going to return, the value that it's going to compute, is whether that number modulo 2 is 0. And that's the definition of something being even, right? So I can put this into Java REPL. Then after I do that, I can just use it. It's even of 3, and what would this return? False, right?
What's 0 going to return?
0? What's 0 going to return? True, right? Modulo 0 is 0. Minus 7 going to return. I can never remember how is modulo defined for negative numbers. It's even of 17? False, right? Yeah, if I do it like, yeah. Does this idea make sense? Cool. We will see how to define functions, and we're going to spend a week defining functions. Important thing to remember, you need to define what value do you return, the name of the function, the parameters, and you need to define their types and the names for those parameters. And then inside you can use the parameters, and they'll be replaced by whatever gets passed, right? So if you call it isEven of 0, then when the function is evaluated, number would have the value 0, right? It's substituted. Return gets you out of a function and yields a value to the caller of the function. Does that make sense? Really cool thing is this allows you to build abstractions, right? Now, rather than have complicated code, I can have code that has, right? Rather than have to remember the modulo operator and how do I define even, I can define this thing and then just use isEven, right? And I don't need to remember modulos anymore. Maybe an operator that you don't use a lot, right? That kind of stuff. when we start seeing more complicated code, you can see that a function or method will allow you to define very complicated operations. In fact, that's how they built all that stuff. That's basically not all you have, but most of what you have. Does that idea make sense? Cool. Then I think I will let you guys go, and we can we'll be here on Monday. Definitely, absolutely try assignment 0. Right? And see you guys on Monday.